Now we are going to start another one question. That is question number 2. In this question, we are going to discuss to find the increasing or decreasing. So our question is find the interval. Find the interval in which the function f(x), the function f(x) is equals to 3x square minus 6x plus 5 is increasing, or decreasing. So at first we have to understand the question. Find the interval in which the function f(x) is equal to 3x square minus 6x plus 5 is increasing or decreasing. Solution. We have here at first f(x) is equals to the given condition 3x square minus 6x plus 5. So derivative of this f(x) is, we know f dash x is first derivative. So here 3 times 2x minus 6 times 1 plus 0. This is equals to, we can write 6x minus 6. This is the first derivative. Now we know f dash x means this first derivative is equal to 0 gives 6x minus 6 is equals to 0. Or if we'll take x 6 common, then x minus 1 is equal to 0. Or we can write x minus 1 is equal to 0. Therefore x is equals to 1. So if first derivative is equal to 0 and then x is equal to 1, which is stationary point. For now, for x is less than 1, f dash x is also less than 0. हेर्नुस् if x is less than 1, यहाँ x चाहिँ यदि 1 भन्दा सानो भयो भने, and then f dash x also 0 भन्दा के हुन्छ, f dash x पनि यहाँ minus 6 छ, त्यसकारणले 0 भन्दा सानै हुन्छ. Therefore fx is decreasing for x less than 1. That is in the interval minus infinity to 1 here. For x is greater than 1, f dash x is equals to 0. Therefore fx is increasing, fx is now x greater than 1, f dash x is equal to 0. So therefore fx is increasing for x greater than 1. That is in the interval, let's look here. Here is minus infinity to 1. Here is 1 infinity due to this 1. So this is the complete answer of this question. Students, now we are going to start another one question, that is question number 3. Question number 3. Our question is find the local maxima find the local maxima and minima. And points of inflection of fx is equal to of the function fx is equals to 3x square minus 6x plus 3. How to solve this question? Now here we have to find the maxima and minima and point of inflection. Solution: we have here the given condition is fx is equals to 3x square minus 6x plus 3. Therefore, the first order derivative of fx is f dash x is equals to 3 times 2 is 6x minus 6 times 1 is 6 and 3 is 0. So we write 6x minus 6 only here. And then second derivative, again second derivative f double dash x is equals to, here is 6x and then here is 6 and then minus 6 is 0 because derivative of constant term is 0. So only 6. For maxima or minima, value of fx, we have f dash x is equal to 0 for maximum and minimum case. So f dash x is equal to 0 means 6x minus 6, this is f dash x, 6x minus 6 is equal to 0, or that gives us x, 6 is common, x minus 1 is equal to 0, and then therefore we can write x is equals to 1. So when x is equal to 1, when x is equal to 1, then f double dash x is equal to 6. Here is 6, which is positive. So fx as a minimum value at x is equal to 1, and the minimum value is, and the minimum value is, we have here 3x square minus 6x plus 3. So we have to put the value of x is equal to 1 in here. So we'll get 3 times 1 is square minus 6 times 1 plus 3. And this is equals to, we have here 3 plus 3, 6 minus 6 is 0. Again we have f double dash, that is second derivative, we have f double dash is equal to 6, and which is not equals to 0 for any value of x. So fx has no point of inflection. Therefore minimum value is equal to 0 at x is equals to 1 and no point of inflection. This is the complete answer of this question. I hope you don't have any question here. Students, we have next one question, that is question number 4. Question number 4. And question number 4, we can make such type of question. Find the absolute maximum and the absolute minimum values of the following function. On the given interval. Now our function is fx is equals to 2x cube minus 15x square plus 36x plus 10 on, and our interval is 1, 4. This is our question. Now solution. Solution, we have the given condition is, we have fx is equals to 2x cube minus 15x square plus 36 plus 10. This is our given condition. Then the first derivative. Then f dash x, this is first order derivative, is equals to, we can write 2 times 3x to the power 3 minus 1 minus 15 times 2 times x to the power 2 minus 1. I think here 36x. So plus 36 times 1 plus 0, and this means we have 6x square minus 30x plus 36. So it gives, when f dash x is equals to 0, when f dash x is equal to 0, and then f dash x means 6x square minus 30x plus 36 is equal to 0. Or we can take common here, 6 common, then x square minus 5x plus 6 is equals to 0. Or we can factorize x square minus 2x minus 3x plus 6 is equals to 0 by 6. It goes to divide. Or we can write x common, then x minus 2 minus 3 common, then x minus 3 is equals to 0. 3 common, then x minus 2. We can write our x minus 2 times x minus 3 is equals to 0. We can write either x minus 2 is equal to 0 and or x minus 3 is equal to 0. Therefore x is equal to 2, x is equals to 3. We have double value. Therefore x is equal to 2 comma 3 we have here. Now when x is equal to 1, then fx is equal to, here is our fx, so 2x cube, 2 times 1 cube minus 15 times 1 square plus 36 times x means 1 plus 10. This is equals to 2 minus 15 plus 36 plus 10, and it gives 36, 37, 38, 48 minus 15 is 33. So again, when x is equals to 2, because here we have to go 1 to 4. Yes, we have 2, 3 here. So when x is equal to 2, then fx is equal to 2 times 2 square minus 15 times 2 cube 2 square plus 36 times 2 plus 10. This is equals to 2 times 2 cube means 8, 8 times 2 16 minus 15 times 4 is 60 plus 32 times 36 times 2 is 72 plus 10. Then 72 minus 60 is 12. 12 and 16 is 28 and 10 is 38. So we have 38 here. Again, when now we have when x is equals to 3, then fx is equals to 2 times 1, 2 times 3 cube minus 15 times 3 square plus 36 times 3 plus 10. This is equal to 2 times 27 minus 15 times 9 plus 108 plus 10. And after calculation, we'll get 37. Again, when x is equal to 4, up to 4 only, we'll calculate. So fx is equals to 2 times 4 cube minus 15 times 4 square plus 36 times 4 plus 10. So this is equal to 2 times 4 cube is 64 minus 15 times 16 plus 144 plus 10. And after calculation, we'll get here 42. Now let's compare the values. Here is 42, here is 37, here is 38, and then here is 33. So which one is the maximum value here? Absolute maximum value here is here 42, and then minimum value is here this 33. This and then these are the maximum and minimum. So therefore absolute maximum, we have to find here absolute maximum and then absolute minimum values. Therefore the required absolute maximum values is equals to 42, and absolute minimum value is equals to 33. This is the complete answer of this question. Students, we completed 4 questions. Now we are going to start another type of model in question number 5. That one is question number 5. Question number 5, let's make a question. Determine where the graph where the graph is concave, graph is concave upward and concave upward, and where the or we can write where it is concave downward. Concave downward of the function of the function our function is, suppose fx is equal to you can write x4 minus 2x cube plus 5, x4 minus 2x cube plus 5. This is our question. Now let us start the solution. Solution here we have fx is equal to fx is equal to x to the power 4 minus 2x cube plus 5. We have fx is this. So first derivative, therefore we can write first derivative f dash x is equals to 4 times x cube, this comes here, n times x to the power n minus 1. So 4 times 4 minus 1 is 3, minus 2 times 3 is 6x plus 0. Again we have to find second derivative. So therefore second derivative f double dash x is equals to 4 times 3 is 12, and x to the power 3 minus 1 is 2, minus 6 times 1 is 6 only. Here is 6x. So here is 3. 3 minus 1 is 2. 6x square is there. So 6 times 2 is 12, and then here is x, 12x. Now we have f double dash x. F double dash x is equal to 0 gives this is equal to 0. This 0 gives 12x square minus 12x is equals to 0. Or we can write 12x is common here. So x minus 1 is equals to 0, or x minus 1 is equals to 0. Therefore x is equals to 1. X is equal to 1. Therefore x is equal to 1. Here again we have to look it. Here if we'll do either 12x is equals to 0 or x minus 1 is equals to 0. So therefore here x is equal to 0 by 12 is 0, and then here x is equal to plus 1. Therefore x is equals to 0 and then 1. Here x is equal to 0, 1. X is equal to 0, 1, which are the point of inflection. We have for x is less than 0. For x is less than 0, then f double dash x, here is f double dash x is this one. So x is less than 0 हुँदा हेर्नुस् त यहाँ हामीले 0 राख्दैछौं, यहाँ पनि 0 राख्यौं. F double dash x is greater than 0, less than 0 हुँदाखेरि, because here is x square and here is x. And then again, for x is or we can say 0 is less than x, x is greater than 0 and then less than 1. Why भने f double dash x is also less than 0. We can put here and we can look. And for x is greater than 1, then f double dash x. If x is greater than 1, then it will be, if we'll put here 1, then it will be, we can see 0. But if we'll put 2, 3, 4, then we'll get the result. So this is also greater than 0. Hence we can write, let's write here. Hence the graph is concave upward for x is less than 0. X is less than 0, then f double dash x is greater than 0. So graph is concave upwards and x is greater than 0 and the graph is concave downward for 0 less or equals to x is less or equals to 1. Here the graph is concave upward for x less than 0 and x greater than 0 and concave downward for 0 is less or equals to x is less or equals less than 1. फेरि एकपल्ट हेर्नुस् है, यहाँ कन्फ्युज नहुनु होला. The graph is concave upward for x less than 0 and then x greater than 0 and concave downward चाहिँ हेर्नुस् त x is greater than 0 and then less than 1 हुँदाखेरि concave downward भयो. हेर्नुस् त यो दुईटा हाम्रो के भयो, concave upward भयो र यो चाहिँ हाम्रो concave downward भयो. यसरी हामीले यो क्वेशन सल्भ गर्यौं. Students, now we are going to start another one question that is also slight different type of question. That is question number 6. Find the two numbers whose sum is 10 and the sum of whose square is whose square is minimum. Our question is find the two numbers. We have to suppose either two number a and b, or we can suppose x and y, whose sum is 10, so plus is 10 and the sum of whose square is minimum. So solution: let the two numbers be x and y. Then x plus y is equals to 10. Therefore y is equals to 10 minus x. We can suppose this is equation 1. Again, if S be the sum of the squares. If S be the sum of the square, here is at first whose sum is 10, so x plus y is equal to 10, y is equal to this we wrote. And the second case is sum of whose square is minimum here our question. So S be the sum, so we can write then S is equals to, we have S is equals to x square plus y square, whose square, sum of square means sum and then this x square and y square. This is, we can say this one is equation, we have equation 2. We can substitute the value here, or S is equals to, what is the value of y from here? So x square plus y means 10 minus x whole square, and now this is equals to x square plus 10 square minus 2 times 2ab plus b square. A minus b whole square is a square minus 2ab plus b square. So this one is x square, and x square we have 2x square minus 10 times 2 20, and then x 20x, and plus here is plus 100. Now we have to find derivative of s with respect to x. So now ds by dx is equals to ds by dx. So d by dx of 2x square minus 20x plus 100. Now this is equals to derivative of this, derivative of this, derivative of this we have. So 2 times 2 is 4x only, 2 minus 1 is 1, and then minus 20 times 1 is 20, and here is 100, derivative of 100 constant term, that one is 0. Therefore ds by dx is this one. Now again we are going to find the derivative, that is second derivative. Again we have d square s, here is second derivative, so d square x by dx square is equals to, we have here d by dx of 4x minus 20, and then this means we have only 4, because this one is 4 times 1 and this one is 0, minus 0 is 4 only here. For minimum, here our question asks about the minimum. For minimum value of s, ds by dx first derivative is 0. So we have here first derivative is 4x minus 20, so we can write, or 4x minus 20 is equals to 0, this first derivative 4x minus 20, or we can write 4x is equals to 20, therefore x is equals to 5. And then x is equal to 5 there, we can write when x is equals to 5, when x is equal to 5, then y is equals to, we have 10 minus 5 is equals to 5. This is from first equation, from equation first. We already wrote the first equation. Similarly, at x is equals to 5, x is equal to 5, then d square s by dx square, this is second derivative, is equals to 4, which is positive. So s is, so s is minimum when x is equal to 5 and y is equal to also 5, because here is y, and then here is x. Same 5 and 5, and this one is positive. Therefore, required two numbers are के रहेछ नि त हाम्रो क्वेशन अनुसार हेर्नुस् त find the two numbers भनेको थियो. Hence the required two numbers are 5 and 5. यसरी we calculated the answer of this question. In this way we completed this exercise. Students, now we are going to start another one topics, and that one is derivative. Derivative as the rate measure. Here in these topics, let's discuss about the problem. So let's focus on from this example. Let's take an example. Example 1 we'll discuss in the example. So let's make one question. Suppose a particle moves in a straight line. In a straight line, the distance, suppose the distance s, measure in meter, cover by the particle in time t, that is also in second, is given by s is equals to 2t square plus 5t minus 4. So find the velocity. Find the velocity. Once again, a particle moves in a straight line. The distance s, measured in meter, covered by the particle in time t, is given by s is equal to 2t square plus 5t minus 4. We make. Now find the velocity, and we can add it acceleration also. Velocity and acceleration of the particle in 6 seconds. Okay, we can write 6 seconds. Students, I think you are clear about the question. Let us discuss about the answer. So here solution, s is equals to, we have s is equals to 2t square plus 5t minus 4. This is s. So let us find derivative of s with respect to t. So we have ds by dt is equals to d by dt of 2t square plus 5t minus 4. So this is equals to, here 2 times 2 is 4t plus 5. Again, d square, second derivative, we are going to find d square s by dt square is equals to d by dt of 4t plus 5, and its answer is 4 times 1. So its answer is 4. Therefore, when t is equal to 6, we have here 6 second time t. When t is equal to 6 second, velocity is equals to, velocity is, we have first derivative, that one is ds by dt. So ds by dt is, we have here ds by dt is 4t plus 5. So 4 times t is, we have 6 here, 4 times 6 plus 5, and this is equals to 29 meter per second is meter per second, because this measure in meter and then time in second. Similarly, and acceleration is equals to, we have acceleration is again d square s by dt square, because we know in science also rate of change of velocity is called acceleration. So we have d square s by dt square is acceleration. So this one is, we have here only 4, that's 4, and this one is meter per second square This is the answer of this question. Here we found velocity as well as acceleration. This question try to give the information about the velocity is the first derivative and acceleration is the second derivative. Now let us go on the example 2. Example 2. So in this example, we have a question. The side of a square sheet is increasing at the rate of 5 centimeter per minute. At what rate the area increasing when the side is 12 centimeter long. Students, here the side of a square sheet is increasing at the rate of 5 centimeter per minute, and at what rate the area increase? Here at what rate area is increasing when the side is 12 centimeter long. So solution, we have to let at first, let x represents the length and a represents the area of square sheet. Then by question we have dx by dt is equals to 5 centimeter per minute. Here increasing at the rate of 5 centimeter per minute. The meaning of that one is this. We know area A is equals to, this is a square, so that one is L square. Instead of L we suppose X square. So A is X square, which implies dA by dt is equal to taking derivative with respect to t. So here is x square d by dt of x square. So this one is d by dx times dx by dt. So this is equal to, this is x square here. So we have here 2x times dx by dt. Now when x is equals to 12 centimeter, when x is 12 centimeter, then dA by dt, this, because here is in our question the side of the square sheet is 12 centimeter given, so dA by rate of change in area, this one. So dA by dt is equal to, we have here 2 times x, is instead of x we are going to put 12 times dx by dt, we have here dx by dt is 5. So this one is 120 cm square per minute here. Hence the area, increases at the rate of 120 cm square per minute is the complete answer of this question.